All right. Fifth period today, I cannot be here because I have to go to a cross country meet, and so I'm going to make a video because it's about where they were, so they can watch the rest of it. Okay, so y'all are, this class is being recorded, so just be careful what y'all say. Ethan, don't be yelling obscenities or anything like that. Okay. All right. So just a real quick reminder. Yesterday we talked about zeros. And we started talking at the very end about this thing called multiplicities. But remind me, what did I mean by a zero? It's where a polynomial function will cross that's exactly right, what you said. Okay, where it crosses the x-axis. So yesterday what we tried to do was we tried to graph a few of these. And of course we use that second trace function, the same function that we used to find the minimum and maximums. We did the same thing to find the zeros. We just used number 2 instead of number 3 and 4. We still had to do the left bound, the right bound, all that stuff. But we did the same thing yesterday, with our calculator as we had done. Then, of course, I tried to show you that sometimes when you graph, like this one right here, sometimes that graph will just go straight through it, like this one does right here, right? But then sometimes it doesn't go straight through it. Sometimes it comes down and it touches, and my iPad's a little laggy. Sometimes it comes down and it touches it, but then kind of just bounces back off and goes the opposite direction. And there's something distinguishably different between the answer to those problems, and that is what we call multiplicity. It means that the answer is the answer a certain mind or conceptual number of times. So like for example this one, when it just goes straight through it, it meant it was our answer how many times? No, when it went straight through it like this one, it meant it was our answer one time. But when it came down and it touched it and went the opposite direction, it was the answer twice. Okay? So we called it a multiplicity. So here's what I told you guys yesterday. If that multiplicity is odd, it's going to cross it. Now let me just quickly remind you. If this is my coordinate plane right here, it's lagging. I don't know why it's lagging, but it's lagging. There it goes. It's catching up now. So if this is my coordinate plane, an odd multiplicity has to go through it, right? Well, if that odd multiplicity is a 1, it's just going to go straight through it. But if that odd multiplicity is like a 3 or a 5 or a 7 or a 9, it's going to go through it, but it kind of does a little curve as it does. You understand that? So odd crosses it, but you even can know the difference between whether it just goes through once or if it's going through 3, 5, 7, 9, 11, and we won't go that high, but you know what I mean? And then we said if it is a multiplicity of 2 or 4 or 6 or 8, if it's an even multiplicity, it's just going to touch it and it's going to bounce right off. So it could do either direction. It could go from down to up. It could go from up to down, but it's going to bounce right off of it if it has an even multiplicity. So yesterday we talked about if they're already written as factors, our process is real simple. We would take them, so we take that x plus 7, set it equal to 0, and solve it. How do I solve that one? I subtract 7, right? So negative 7 is one of my what? Negative 7 is one of my zeros. Now, how many times was it one of my zeros? Twice. So what did that mean the effect was? Does it cross or touch? It touched. Okay? Touched. At that spot, negative 7, we can know that we would see that graph either come down or come up to a point, hit it right at negative 7, and then turn back the opposite direction. I know it will do that because it has an even multiplicity. And we did the same thing with the rest. We do 2x plus 1. We set it equal to 0. Wouldn't I subtract 1? Then divide by 2. So negative 1/2 is one of my what? Negative 1/2 is one of my zeros. Now, how many times when there's no exponent there? Once, right? If there's no exponent there, it's understood to be a 1. So what would the effect be at that point? It crosses it. Okay, it crosses it. And then the last one, of course, the factor is x minus 4. We set that equal to 0 and solve. We add 4. And how many times is 4 a 0? 3 times. So what's it going to do there? It's also going to cross. Now, I bet y'all, hopefully y'all remember, it won't cross the same way that one did, but it'll do kind of a little wiggle. And you don't have to show that. I'm just making a point that there is a difference between. Now, here's the ones that are a little harder. Number 7. And listen, there are 2 really good ways to go about this. And I'm going to show them both to you right now, okay? 1, old school. Old school, I could factor these, couldn't I? So if I factored these, what do y'all notice that all 3 of these terms have in common? An x squared. I could pull out x squared. That's a GCF. Well, x to the 4th divided by x squared is x squared. Negative 2x cubed divided by x squared is negative 2x. And negative 8x squared divided by x squared is negative 8. Now all of a sudden, keep x squared, but now all of a sudden I have a trinomial that we can try to factor into what? 2 binomials. Let's give that a go. What multiplies by itself to get x squared? So we got x and x. What multiplies to get a negative? A positive and a negative. And then, of course, we're looking then for the 2 numbers that multiply to get 8. But because those signs are different, has a difference of 2. It's got to be 4 and 2, right? So my last thing is this. If negative is the sign in the middle, it has to go with my bigger factor, which is which one? So it's x minus 4, it's x plus 2. Okay? Now I'm going to pause there for just a second. And I'm going to show you the other method and then let you guys determine for yourself which one would y'all prefer. The other method, since we've learned it now, is the graphing calculator. So look, I'm going to grab my TI-84 Plus, and I'm going to graph this original equation. Okay? Graph the original equation. X to the 4th minus 2x to the 3rd minus 8x squared. And I'm going to graph it. Now, here's the point. Yesterday and today so far, we've talked about this. What is it doing right here? What's it doing right here? It's going straight through. It's crossing through at what value? Negative 2. Guys, doesn't that mean one of my zeros is negative 2? Now, does it kind of bend through there, or does it go straight through? So wouldn't the multiplicity be a 1? Guys, what's it doing right here? Is it crossing through? No, it's touching it. And where is it touching it? At 0. So what does that mean the multiplicity would have to be there? 2 or some even number, right? 2 or some even number. We'll talk about that in just 1 second. And then right here at 1, 2, 3, 4, what's it doing? It's crossing straight through. So that means 4 is your multiplicity of what? 1. Now, go back to your paper with me. And I hope you see this. How many zeros was this supposed to have? 4, right? Well, if negative 2 is one of them, and 4 is one of them, and we said 0 had to be even, What even number adds up to equal 4? So we know it was a multiplicity of 2. Now let me show you something. Okay, are y'all looking? Where did I get those numbers on that right side? I got them straight from my graph, didn't I? I got them straight from my graph. But the numbers on the left, didn't I factor? Now look, guys, I want you to put this together. If my 0 is -2, what would the factor be that gives me a 0 of -2? Could I work backwards to get that? If my solution is 0, what factor gives me 0? X. It's a multiplicity of 2. That's where the square comes from. Y'all see that? And then what factor would have given me a positive 4? Y'all see how those all match up? So we factored it old school, and we could have now taken those factors, and we could have done what we did right above. We could have taken x, set it equal to 0, and solved, and said, hey, that's a multiplicity of 2. We could have taken x plus 2, set it equal to 0, and solved, and hey, my answer is -2 with a multiplicity of 1. I could have taken x minus 4, set it equal to 0, and solved, and I could have said, hey, my answer is 4 with a multiplicity of 1. Either way, it leads me to the exact same answers. Y'all see that? I don't care which method you use. Factor it. Use your calculator to find the factors. I don't care. They both do the same thing. They both accomplish the same thing. So it's up to you. So let's finish this one off, and then we'll be done with this problem. If it has a multiplicity of 2, guys, what's the effect? Huh? Not touch. Touch is even. It's odd, so it's going to cross. Now, what about the next one, Alexis? Touch. Yeah, that one's a touch because it's an even multiplicity. And then lastly, that last one's it's gonna cross, which we saw that, right? We saw it on our graph, and that's true with all of those. They all match exactly what we have here. Okay? Questions? So I'm literally done. Okay? I've dealt with everything I feel like you need to know, and I've reviewed it. To find the solution, the x-intercepts, or what we call the zeros, we can use our graphing calculator. We can use the second trace function just like we did with the minimum and maximums. And we said that when you visualize or when you see that polynomial cross through, that's telling me something about its multiplicity, how many times that can be the answer. But if you see the graph touch it and come back up, or come up, touch it, and go back down, that's telling you something else. It's telling you it's an even multiplicity. So with all of that, you should be good to go. All right? Now, we kind of did the way I did yesterday because I wanted you guys to have time. I didn't want you to have homework yesterday because I knew there was a lot going on. I didn't want you to have homework over the weekend because I know there's a lot going on. So this gives us an opportunity to finish this homework before class is over. Okay, there's 6 problems on the front that I want you to do, 1 through 6. And there's 2 problems on the back at 9 and 10. You do not have to do 7 and 8. Okay, we'll save those for another time, or we won't. Either way. But your homework tonight is 1 through, well, hang on. Your homework right now is 1 through 6 and 9 and 10. Okay? 9 and 10 kind of puts it all together. We got to find our mins and maxes and our zeros and graph them and talk about all those things we've talked about. Okay? So work on that now. When you're done, you have no homework.